Okay, let's look at some problems from the 5.4 homework, and we're going to start by looking at number 3. And this says, find k such that the function below is a probability density function over the given interval. And then go ahead and write your probability density function. So, first off, it gives me an interval that I'm working with. And I'm only concerned about this interval because I'm only looking over the given interval. That means this is my domain. And then it gives me my function equals kx. That means x, of course, is my variable, and k is what I'm solving for. What is k? So that this is a probability density function. Now, I do want to point out this type of equation doesn't qualify as a uniform or an exponential or a normal, but it can still be a probability density function even if it doesn't fall under one of those categories, as long as that first property is true. I mean, I guess we could look at some of the other properties. If I look at property 2, 2 just says the height of the function, the value of the probability function has to be greater than or equal to 0 for all x values. So if I look at plugging in numbers between 4 and 6, how do I make sure that f of x stays greater than or equal to 0? I can make sure that stays true as long as I know that k has to be positive. But what about property 1? Property 1 tells me that the area under the function within its domain has to equal 1. Well, I can set that up using an integral. The definite integral over its domain, 4 to 6, of my function, which is kx, has to equal 1. So let's go ahead and do this. Let's go ahead and calculate this definite integral. That means I need to find the antiderivative of my function, or I guess, first off, k represents a constant, meaning I can pull it out in front of my integral because it's not going to affect the antiderivative. So what's my antiderivative of x? I get x squared over 2, and that's evaluated from 4 to 6. And I eventually want this to equal 1. Okay, I'll plug in my bounds, and I get 6 squared over 2 minus 4 squared over 2. That's using the fundamental theorem of calculus. Simplify this a little bit, and I get 36 over 2, which is 18, minus 16 over 2, which is 8. And I get 18 minus 8 is 10, so I get 10 times k equals 1. What does k have to be? K has to equal 1/10. So, in order for the area under this function between 4 and 6 to equal 1, k has to equal 1/10. That's what's going to make this a probability density function. If we check that with what we already decided in property number 2, property number 2 just tells me that it needs to be greater than or equal to 0. 1/10 counts as being greater than or equal to 0. So this gives me my probability density function of 1/10 x over the interval 4 to 6. So the big idea here is we're finding the k value that will satisfy property number 1, right? That the area over its domain will end up equaling 1. And if you're curious, right, if you want to make sure this works, you could just try it again with that 1/10 plugged in. Go ahead and take the antiderivative here, use the fundamental theorem of calculus, and make sure you end up equaling 1. Okay, let's look at another problem. Okay, the next one I want to look at is number 6 from your homework. And this one, the time to failure in hours of a machine is often exponentially distributed with a probability density function of f of t is equal to k e to the negative kt over from 0 to infinity. So what does this look like? This is an exponential probability density function, which I talked about earlier. And you'll notice I have this equation of f of t is equal to k e to the negative kt, where k is equal 1 over a, and a is the average amount of time that will pass before a failure actually occurs. So suppose that the average amount of time is 80 hours before a failure happens. Well, just by knowing that value, I can now actually write my probability density function without all the letters, at least without the k's. What is k going to be? K is going to be 1 over my average time, which is 80. So I get 1 over 80 e to the negative 1 over 80t. That's your probability density function. And so now look what it's asking. What is the probability that a failure will occur in 51 hours or less? So what am I giving you here? I'm giving you an interval, and I want to know the probability that my value lies within that interval. This is property 3. Property 3 says, hey, I can find that probability by just finding the area under the function over that interval. So that's what we're going to do. We're going to find the area under this function from, what's my interval? If I'm looking at 51 hours or less, I'm going from my very lower bound, which is 0, to 51. What equation am I integrating? I'm integrating the probability density function. Okay, so now I've set it up. Now all I have to do is actually calculate this integral. Well, I can pull out the 1 over 80 because it's just a constant. And now I have an exponential function that I know how to find the antiderivative of. My antiderivative here is, I'm going to keep the e to the negative 1 over 80t, and then I'm going to divide by that constant. I'm going to divide by negative 1 over 80. And then this is bounded from 0 to 51. Now, dividing by negative 1 over 80 is not very pretty. So remember, if you ever divide by a fraction, you can instead flip and multiply. So instead, I get 1 over 80 times, flipping and multiplying, I'm just multiplying by negative 80. And that's evaluated from 0 to 51. Well, these are just constants, so I can go ahead and evaluate that right now. What's negative 80 times 1 over 80? I just get negative 1. So I get negative 1 times, and I'll also go ahead and plug in my bounds here. So I get e to the negative 1 over 80 times 51 minus e to the negative 1 over 80 times 0. Okay, so I get negative 1 times, this first one I'm going to need a calculator for, and I get 0.5286, and I'll stop there. Minus, when I plug in 0 though, I just get 1. And so when I finish my subtraction and multiply by negative 1, I get 0.47138. I'll round to 4 decimal places. So what does this number mean? I get this 0.4714. This represents a probability. So if I convert that into a percentage, I get 47.14%. There is a 47% chance that my machine will fail within the first 51 hours. And that's what that value means. Okay, very nice. If you still have questions on the rest of the problems, go ahead and shoot me an email, but that takes care of 5.4. So I'll see you in the next video where we'll talk about the normal distribution, the normal density function, as well as how to calculate expected value and other things like that. Okay, good luck everyone.